Hey guys, welcome to the shop. So, this is kind of an interesting project. I had an old cast iron window weight, which I don't know if you're familiar with old houses, but they used to counterbalance them so they were easier to open and close. In I mean, this is really just rough machining to profile. I've already squared the stock somewhat, and it wound up being a really tough project. This has all been filmed up to my stopping point at time of this recording. To be honest with you, I've kind of temporarily tabled it because this wound up being too hard to scrape flat. I mean, we got it really, really flat. I think we had 40% contact on the ground surface. Uh, it's the downside to these window weights is they're extremely hard. It was impractical to scrape it. Uh, we got away with machining it because I was using carbide. And to be quite frank with you, I've gotten so used to machining steel, I didn't even notice that this was tough. Uh, it, just live and learn. But you can see, I mean, we do take some heavy climb milling passes on it. I think we got away with that because it was cast iron. And I mean, we really were hogging off material. And we do get to do some fun setups. Like I broke out the angle plate for it, and it was an interesting experience. So this wound up needing a lot of stress relief. It warped significantly, and the real turning point where I decided to not scrape it in is I ground it, left it in the shop overnight, and it moved again. Where there's so much stress in this piece, I know I need to stress relieve it. But if you've been following the weather in New England, it has basically not stopped raining for a month. It's too wet for me to build a fire outside to stress relieve it. So I'm going to wait for the weather to dry out, and I'm just going to throw it in a campfire overnight, descale it, and scrape it. But, it was definitely an interesting project, and I think I learned a lot. So here we are with the hand camera. The blank is pretty roughed out. You can see how it's vaguely dovetail shaped now. What I'm going to do actually is mill this side flat. I'm just going to hang it in a vise because I want something that's going to be easier to hold onto, and I think I'm going to grind this. I'm not sure how I'll fixture it, but I want to figure out a way to grind the bottom side before I scrape it, because that'll just save me a ton of time. And this will also need to get stress relieved. It moved noticeably during machining, which is unfortunate, but also not terribly surprising. And you can see we made quite a few chips today. It's going to be a little bit of cleanup when we're done. While this is set up, excuse the smash cut back to the exact same thing, I want to talk you guys through why this is a very bad setup. And if I had any other options, I wouldn't have done it this way. This step block here is a problem. That lets this twist and can let go. These aren't thick enough, but I couldn't find any screws longer. And you see I've got flatheads in here, not even socket cap screws. So it's not very rigid. And what I had to do for the bulk of the material removal is I had to push this way with the cutter and be extremely careful at no points to climb mill, because I did let myself climb mill a little bit and it pulled the whole part out because I don't have enough clamping force. I think what I should do is buy some longer, probably an inch longer than this socket cap screws, maybe even more, so I can use better, thicker hold downs, not just random chunks of scrap iron. And also buy more step blocks, just because that'll make life a lot easier. If you can hold it tightly, you can take material off faster instead of playing tickle monster at it. And taking a 15 thou depth of cut at a time, or even 30 thou depth of cut. So it's pretty exhausting doing it this way because it's just so much extra cranking. So here we are over at the mill. This is quite hot, and as you can see, we've made a lot of chips. The window weight I started with had quite a few casting flaws. And to be completely honest, I forgot to hit record. For this last pass, I was taking out a couple of voids. What you didn't see was there was just basically pockets. So this is quite a lot thinner than I would have liked. However, I think it's still going to be rigid enough for the application, i.e. a straight edge. I'll just have to be really careful handling it. The rough machining's pretty much all done. What's left to do is I'm just going to clean up the other side, and I think I'm going to leave this web here, which I was originally planning on removing, just because I do want to give this as much mass as possible. And this is basically a one-time use tool. It's just to repair one of the dovetails on my lathe, not even both. So I'm going to clean the machine off, do the next setup, and you can at least watch that machining. It's just, this is a lot of iron. I think I've made probably 5 or 6 pounds of chips just on this project alone, and it's a huge mess. You wouldn't believe the floor. Okay, so I just took it out of the vise. I wanted to show you guys what I was talking about. You see this peeling, basically. Focus. Focus. It's not focusing. But you see, there we are. You see how those chunks are just getting peeled out. I switched to a much smaller end mill because it really reduces the incidence of that. I think we're going to have enough surface to do what I need to do, but it's going to be tight. So we're over here on the surface plate. I don't know if the camera mic will pick this up, but it rocks, and I can feel quite a lot. Also, when you hinge it, it hinges unevenly, so it's kind of, it's high in the middle, is what it feels like to me. So I'm gonna hope I have enough surface area here to hold it down, and I'm gonna try grinding it quickly, and we'll see if that makes a big difference. And I know it will. I'm just hoping I can hang on to it. So this side is not even close to flat enough to sticking on the mag chuck. It still rocks even when I mag it down. So I'm going to grind the top, and then I'm going to grind the bottom. So I'm just going to let the machine warm up while I get my PPE and my respirator on. So, in an effort to not bore you guys to death, I skipped a lot of the grinding. We're kind of back at the more finesse end, not rough grinding. Uh, Spoiler alerts, this had a huge low spot in the middle. That ties in with what I saw off the mill. I'm starting to wonder in editing now if the belly we saw in the part was actually stresses being relieved. Where if this was water cooled, there'd be more stress in the ends where it was harder. Uh, that's just a theory. But as you can see, I mean, this is a pretty slow process on the grinder. I'm putting some stick lube on here on the wheel and the part because that helps keep the wheel run a little bit cooler. I get a little bit less distortion. And I'm taking really, really light cuts on this. But we're doing a pretty aggressive step over, so it's like 50 thou a pass. Once we get into finish grinding, I tend to take 10 to 15 thou a pass just because I really want to maximize my flatness and put as little heat in the part as possible. What typically happens on a manual grinder with no coolant is I will leave the spindle running, but go walk away, take a drink of water, give myself a couple of minutes to let the part, stabilize in temperature, and then do my finish pass. And what happens is the ends are still a little bit high compared to the middle, because you see how the part's at an angle. That's so my passes are as short as humanly possible, because the less time the wheel's in contact, the less time it and the part heat up from the friction of grinding. And that's one of the things you really have to learn, is grinding is mostly about heat control. There's no way around it, unfortunately, without going to flood coolant, which this grinder doesn't support without a lot of modification. A mist coolant system is on the horizon, but kind of far off, because frankly, I just don't want to deal with it. And as much as I use the grinder on YouTube, basically all of the times I'm using my surface grinder, it gets filmed. This is not a very heavily used tool. Uh, it maybe sees an hour a week of use, and setting up even mist coolant costs money. It takes up space. I have a really cramped shop. And frankly, I'm selling my second grinder, which is the one I don't use in videos as much, because my good grinder has a couple extra features. It has the rapid traverse wheel. It's already got a light on it. They're both pretty much the same functional accuracy. My gray grinder does have a little bit more wear in the saddle, but once you grind in the mag chuck, that kind of doesn't matter, because the table traverse is still in very good shape. Unfortunately, and this is a really common thing, at least with these Boyer Schultz, is the cover that protects the right hand waves was broken off in transport at some point, and the grinder was put back into service without even a rubber guard, so grit got in that side. And combined with kind of limited oil flow from old felt, it did a lot of wear. What can be done is it could be rebuilt. You could rescrape it and drop it down, but frankly, it's sufficiently accurate. So what I'm doing here, or about to do on camera, is this is dressing the wheel. This is a single point diamond tool, but you see how the wheel is pretty black. It should be closer to a white gray. I'm going to dress the wheel and clean it back up and do my finish pass. So this is one of those kind of art of grinding things, where how much to dress the wheel and how fast to move it can make a pretty big difference in surface finish. Moving it quick, you get a more or less open dress. Moving it more slowly, you get a more closed dressed, and somewhere in the middle, it kind of averages out. I like to move relatively quickly, because I do prefer an open dress, especially grinding cast iron. That's just my preference. I know a lot of other people feel differently. You see the amount of dust that blows off. This is where the real mess of surface grinding comes, is dressing the grinding wheel. But you have to do it. And this is can be tough, because if you're grinding to dimension and you've only got a couple 10,000ths of an inch left to go, ooh, touching off for the first time can be stressful. So I like a really bright light, and you just look for the light between the part and the wheel and hope. It's one of those things with practice. I can get about 2/10,000ths of an inch of dimensional, plus or minus, on this grinder. I try to err on the plus side, because as things wear, they'll come into true dimension. But, can't always do that. Sometimes you wind up undersized, unfortunately. But it's this has been a really tricky grinding project, because this turned out to be a really difficult part to hold on to. I kind of made some mistakes in that regard, and it had a lot of casting flaws, so I needed to take off a lot more material than I was originally planning on to get a solid surface. But the iron is also just so unbelievably brittle, it's chipping out in the corners. So, I have a pretty good ground straight edge. This is all filmed and getting edited, so the straight edge is pretty much as done as it's going to get, and it's ground, I would say, very well. On the surface plate, I have like 40 to 60% contact after grinding, but it moved overnight. There's so much stress in this part, it continued to move, so it needs to get stress relieved at some point. And that's kind of the tough thing about salvage materials. You don't really know what you're getting into. If hindsight being what it is, I almost wished I spent 60 or 80 bucks on either buying a piece of Durabar or even buying a straight edge blank. But, live and learn. I think this was a pretty good project and it's fun to learn together. We get to see a few grinding techniques and I pull out the stops in the next video to really grind beyond what you can think you can do. Where one of the things to consider is this mag chuck can deform parts pulling it down. There's a lot of force that goes onto it. So, when you have a couple tons of pulling force, you might deform your part just magging it down. And, we kind of figure that out together. If you really got flat parts and you need to deform them, if you've got enough stock, you can mag it down, knock off the high spots, flip it over, and kind of just keep flipping until it comes in flat. Or you can shim it, or you can use my trick that I show you. But all of these really do require a bit of care and creativity, where the hard part of a surface grinder is work holding. Once you figure out how to hold on to it, things kind of fall in place. That the grinder's pretty forgiving once it's running if you work slow enough and work careful enough. But, it's just holding the parts. I only grind ferrous materials. If it's not magnetic, I don't want to deal with it. I know a lot of people grind aluminum, they grind copper, non-magnetic materials, but those require some more creative work holding. Eventually, we're going to finish my Toolmaker's Vise, or I'm just going to buy one. I think, in all honesty, I might buy one. I kind of want to break from these side projects. I mean, they're really fun, but certain shop-made tools, it's better and easier to just buy them, because a lot of this precision stuff's pretty tough on manual machines. So certain precision tools are worth making yourself if they're cost prohibitive. But when you can get an Asian import Toolmaker's Vise for, $70 after shipping, that really doesn't cover materials and consumables. So if the goal is to get a usable tool, it's often better to buy them. But if the goal is to make a tool and learn how to make the tool, absolutely make them yourself. You can't beat the experience. And this project here was mostly experiential learning. It wasn't about the end goal, because the end goal isn't really important. It's not really that important for me to have a straight edge, because the thing I want to use a straight edge for isn't really that important to do. So, it's all about just learning for the sake of learning and trying something new, where I don't have a lot of machine experience machining or grinding cast iron, because it's not what I do. I'm mostly working steel, and I think that's one of the reasons that I got caught up and made that mistake of not really registering how hard this was, because I'm so used to machining steel. So even hard cast iron machines pretty easily. So, live and learn, guys. And thanks for watching. In the next part, I think we're going to have our pretty well ground. I'm going to at least show you me trying to scrape it and struggling through. So, I'm sorry to spoil the ending for you guys, but not every project is successful. And I think that's something to remember, where this channel's kind of geared towards more of the hobbyist or guy getting started. So I think it's good to show people that not everything works. When you're editing a video, people only see exactly what you show them. So, I'm going to show you some mulligans and failures, because there's no shame in failure, especially with something like this.